graph. It's always y, versus x. Okay? So if I give it like this, position time graph, then it means the position is on the y-axis and on the x-axis I have time. Alright, Relo, please just show the class with your hands. Where is y and where is x? Yes, so y and x. So we read it position time graph from left to right. What's wrong? Is that an easy question? Are you scared for your question? Alright, let's read and then I'll explain further. It says there, position time graphs drawn on the pages have a specific shape for a specific motion. Okay? Motion like constant velocity or increasing speed or decreasing speed. On the position time graph, the y-axis represents the motion, the position, and the x-axis represents the time. That's what we just said. Then the gradient. Hope. How do we calculate the gradient again of a graph in mathematics? Hope. Yes? Okay, so that's what you did in mathematics. Yes? But Khali, I have a saying in class, scientists are lazy. But effective. You can't stop at lazy, then you're not a scientist, then you're just lazy. Lazy but effective. So we want to write this in a shorter way. Okay? Now what did you write down here in mathematics? You said the second y coordinate minus the first y coordinate. So if your graph looked like that, and this was your second coordinate and that's your first coordinate, right? Then it's basically your final one minus your initial one, or your last one minus your first one. Yes? And that we write down in science, so we will say yf minus yi, xf minus xi. And Tando, what does this I stand again for? The start there, initial. And we write this in a shorter way. We say the change in y over the change in x. You remember that? Donkey. Okay. Now, what type of graph are we busy with here? We're busy with a position time graph. Position is x. Time is t. Okay. Right. So I can go substitute these symbols in here. So now be careful. This x does not represent the x-axis. This x represents distance or position or displacement or whatever. Okay. So I can write this down as the change in displacement over the change in time, or the change in position, or the change in whatever. Okay. Ona, what do we measure position in again? What's the unit? For position or distance or displacement? Meters. And Akama, what do we measure time in? Seconds. And this is the same as meters per second. Okay, ma'am, what are you busy with here? I lost you. We just proved that for a position time graph, the gradient gives you meters per second. Okay, so we proved that the gradient gives you meters per second. What is measured in meters per second now, Carlo? Distance is meters. Velocity is measured in meters per second. Okay, so you need to know that if you get a position time graph and I ask you, what does the gradient represent? You need to know its velocity. Or I can give you a graph and then ask you, go calculate the velocity. And then you should not think, but where, man didn't give us anything. You should know, if I ask you calculate the velocity, I'm basically asking you calculate the gradient. Are you with me? Okay, let's see how that works. It says there, a bus moves at a constant speed in town. After 5 minutes, it travels at a higher speed, so it goes faster on the freeway. After another 10 minutes, it is forced to stop because of traffic. We can represent the motion on the graph as follows. So here you see we have position versus time. Here the time is in minutes. Okay, so you can see here we have a certain gradient. And then you see the gradient goes up like that. It's steeper. What does that change in gradient represent? What does it show us, Moao? It increases speed because the gradient increased. Gradient is equal to velocity. So if the gradient is steeper, then the velocity is steeper. And then you see here the gradient is what? Constantly what? Here it's also constant. Here it's also constant. Constantly. You are here like the different sides. Does it have a gradient here? If this value here is 20, how will you calculate the gradient? 20 minus 20, because 20 minus 20 gives you over whatever, gives you 0. So because the gradient is 0, it means the velocity is 0, meaning it stopped. Can you see that? Okay, so here it says a gentle slope, says a low speed. A steep slope, higher speed. Graph is horizontal, bus stopped completely. Okay, now let's do calculations. Okay, it says there, Bukamuso, are you awake? No, you're not. I'm asking a silly question. Is jy hier? Okay. All right. Grade 10.